So in this lecture, we will be following a few sums on the expansion using the factorial formula. So in here, what we have is this question where we are asked to expand this term given in here up to and including the term in x cube. So we have to expand up to x cube first, and then we have an additional part to this question. So let's first expand and then take a look at this one. So in order to expand, so the expansion term given to us is root over 4 plus 6x. Now we know that in order to expand, we need to have everything in the numerator. There cannot be any fractions. So we must bring it to the numerator. So if we bring it to the numerator, we have to first convert this into a power. So we know for square root, the power becomes half. So we have 1 by 4 plus 6x to the power of half. And now when we take this in the numerator, we are going to get 4 plus 6x to the power of minus half. But we know that because we have a negative and a fractional power in here, we cannot have 4 in here. So we must have 1 instead of 4 in this place. In the first place, the first term has to be 1. So what will we do? We will take 4 common from 4 and 6x. So what we do is we take 4 common from 4 and 6x. So if we take 4 common, the first term becomes 1 and the next term becomes 6x by 4. So this gives us 4. On the outside, we have 1 plus 6 by 4 gets simplified to 3 by 2x. And then over the entire thing, we have a power of minus half. Now, because we have a power of minus half in here, we know that we can distribute this power over both 4 and 1 plus 3 by 2x. So we will do that. We have 4 to the power of minus half and 1 plus 3 by 2x to the power of minus half. Now 4 to the power minus half from your calculator is going to give you only half. So you will get a half in here and you have 1 plus 3 by 2x to the power of minus half in here. Now 1 plus 3 by 2x to the power of minus half is now completely ready for us to apply the formula. So we will apply the formula and what do we get? We know that half will stay in here and then inside the bracket we are going to do the expansion. So for the expansion we know that the first term is 1 and the next term is going to be n and then ax term and then we have n minus 1 divided by 2 factorial into ax square, and then the next term would be n minus 1, n minus 2 divided by 1, 2, 3, so 3 factorial, and then 3 by 2x to the power of q. So from here, we are going to get half stays as common. We first simplify the parts inside the bracket. So 1 will stay as 1. Then the next term, you need to multiply half with 3 by 2. So that's going to give you minus 3 by 4. X. For the next one, you have to multiply half with minus half minus 1. So that gives you minus 3 by 2. And then you have divided by 2 factorial and 3 by 2 whole square. Because we will put everything in the calculator apart from the x, right? So you're going to put this in the calculator, this in the calculator, this one also, this one also. You just don't put the x. So the x stays as it is. X will stay as it is. You have a square over x, so it stays at there. And then the rest of the part you put in the calculator and you get 27 by 32. In the same way, what you do is you put minus half, minus 1 by 2, minus 1 by 2, minus 1, minus half, minus 1 is minus 3 by 2, and then you have minus 5 by 2, I guess. And then you have divided by 3 factorial. So if you put this in the calculator along with the other parts, you are going to get minus 135 by 128, and then there's this x cube in there, so you put that. Now when you multiply half with everything, you're going to get half minus 3 by 2 fours are 8x plus 27 by 64 x cube, and then minus 135 by 128 into half, which gives you 256. Sorry, this one would be x squared. And this one will be x cubed. And you are done with the expansion. The next part of the expansion says, sorry, the next part of the question says that you have to state the values of x for which the expansion is valid. So what is the value of x for which the expansion is valid? We have seen that in order for the expansion to be valid in case of negative or fractional powers, this part, the second part, must be in between minus 1 to 1. The absolute value of this one should be in between minus 1 to 1, right? Should be less than 1. So it should be 3 by 2x is less than 1. So it gives you x is less than 2 by 3. In the main question, it was that we had to state the value of x for which this expansion was valid. And when we attempted to expand this, we saw that the part where the binomial expansion is to be applied is this part. So if this part is valid, then the whole expansion is valid because you're just multiplying half to it. So in order for this part to, the whole part to be valid, we know that the second part of the expansion, it has to be in between minus 1 to 1. So we did the same thing in here. We took 3 by 2x in to be less than 1, and we know that we have to find out the range for x. We have to state the values of x for which the expansion is valid. We need to state the range of x. So in order to find out the range of x, we need to isolate x from here. So if you leave x and take everything to that side, what do we do? What do we get? So we have 3 by 2 in here, and we know absolute value turns everything positive. That is just its function. So 2 is already positive, 3 is already positive. You don't really need to worry in here. So 2 is divided in here. It goes to the other side, gets multiplied with 1. So you get 2 in there. And then there's this 3 multiplied with x. So it goes to the other side and gets divided. So this is our range for x. Now in this question, the second one, we are asked to expand in ascending powers of x up to and including the term in x cube. So up to the term in x cube, we have to expand, and we need to simplify all the terms as far as possible. So let's begin with our expansion. So in the first case, we are asked to expand 1 minus 3x by 4 to the power of 1 by 3. Now 1 minus 3x by 4 to the power of 1 by 3. 1 by 3 is an indicator that we need to use the factorial formula. And in order to use the factorial formula, our first term must be 1, which we already have in here. So we can start with the expansion right away. So we will have 1 plus, this is our n, and this is the ax part where we have a minus in here as well. So we have 1 plus nx, nx. Then we will have n minus 1 divided by 2 factorial into minus 3 by 4x squared. And then we will have the next term, because we are asked to expand up to the term in x cube. So we will have plus n minus 1, n minus 2 divided by 3 factorial, because there are 3 terms in here, and then minus 3 by 4x whole cube. And because there are other terms, we will put dot, dot, dot. So in here, what do we get? If we use our calculators, we are going to get our first term is going to be 1. Then the next one, when we multiply, we are going to get minus 1 by 4x. For the next one, when we multiply, we are going to get minus 1 by 16 x squared. And for the next calculation, we are going to get minus 5 by 192 x cube. And we will not write the other terms. Then in the next part of the question, we are asked to expand this expression. Now it is a similar expression to the previous one, but here the power is negative and the ax term is positive. So in the same way, what we will do is we will write down the expansion for this one. So if we write down the expansion for this one, we are going to get 1 plus 3x by 4 to the power of minus 1 by 3 negative 1/3. So in the same way, our first term is going to be 1. The next one would be minus 1 by 3. Then we will have plus 3 by 4x. Then the next one will be minus 1 by 3, minus 1 by 3, minus 1, n minus 1 divided by 2 factorial. And then we have 3x by 4 whole square. And the next term would be n minus 1, n minus 2. There are 3 terms, so 3 factorial, and then we will have 3 by 4x whole cube. So when we do this, our expansion gives us the following result, which is 1 and then minus 1 by 4x. Then we are going to get 1 by 8x squared. And then after the calculation, we are going to get 7 by 96x cube. And then for the other terms, which we are not writing, we will write plus dot, dot, and dot. So now it says in the third part of the question, the first 2 parts were easy expansion. And in the third part of the question, it says write down the range of values of x for which both of your expansions are valid. So we know for both the expansions to be valid, the second term, the highlighted term 3x minus 3x by 4 and 3x by 4, both of these, they have to be in between 1, minus 1 and 1. So for the third part of the question, see your first expansion dealt with minus 3 by 4 as the second term, right? You had minus 3 by 4 in here. So minus 3 by 4x is supposed to be less than 1. Now we know the job of these brackets, these vertical bars, is to make everything positive. So this negative sign will definitely turn positive and we will get 3 by 4x is less than 1, like this. So now this 4 is divided in here, it will go to the other side, get multiplied. This 3 is multiplied in here, it will go to the other side and get divided. So we are going to get x is less than 4 by 3. Now for the other expansion, we have 3 by 4x. So if you put 3 by 4x is less than 1, you are going to get the same thing as this one. So we are going to get x is less than 4 by 3 again. Both of these are the same thing. So you can just write either of these. It's the same thing. Now let's move to part D of the question. In part D of the question, it says you have to expand 4 minus 3x by 4 plus 3x, this fraction, in ascending powers of x up to and including the term in x cube. So now you have to expand this fractional term which is given to you, and this fraction is raised to the power of 1 by 3. So you are asked to expand 4 minus 3x divided by 4 plus 3x to the power of 1 by 3. Now, in order to expand, we know that we have to take everything to the numerator. So, if you take everything to the numerator, what will you get? You're supposed to get this raised to the power of 1 by 3 and then this one again raised to the power of 1 by 3. So there are two approaches to do this one. The first one is you take everything to the power of 1 by 3 separately, which is you have 4 minus 3x to the power of 1 by 3, and then you are going to raise this to the power of 1 by 3 also. So you can write it like this: 4 plus 3x to the power of 1 by 3. Now, we know for the expansion, you can take this one in the numerator. So you are going to get 4 minus 3x to the power of 1 by 3 and then 4 plus 3x to the power of negative 1 by 3 because you're taking this in the numerator. So now you can take 4 common from here and from here as well, because in order to expand, you need to have the first term as 1. So if you take 4 common from here, you're going to get 1 minus 3 by 4x to the power of 1 by 3. And from here, you're going to get, if you take 4 common, you're going to get 1 plus 3 by 4x to the power of negative 1 by 3. So if you expand this, what do you get? So before expansion, we have a 4 in here. So we will distribute the powers. So we will get 4 to the power of 1 by 3 and then 1 minus 3 by 4x to the power of 1 by 3. And then from here, we have 4 to the power of minus 1 by 3 into 1 plus 3 by 4x to the power of negative 1 by 3. Now, because these two are numbers, you have a number in here multiplied with another number in here. So what do? We multiply these numbers and we get 1. So we are left with 1 minus 3 by 4x to the power of 1 by 3 and 1 plus 3 by 4x to the power of negative 1 by 3. Now these two expansions, if you notice, you have found out previously. We have just done the calculations in here for these expansions. So we will copy these down. So let me write it in here. So we got the first one. And the next one which we have is this one right here. So we will copy this one as well. So we need to multiply these two in order to get the expansion up to the term in x cube as mentioned in the question. So you pick one term and then you keep on multiplying, just how we have done the expansions normally. So 1 multiplied with the entire thing gives us 1 into 1, which is 1. Then 1 into 1 by 4x, it will give you negative 1 by 4x. Then 1 into 1 by 8x squared is going to give you 1 by 8x squared. Then 1 into this is again going to give you 7 by 96x cube. Then we will take it minus 1 by 4x. So minus 1 by 4x into 1 gives you minus 1 by 4x. Then minus 1 by 4x into minus 1 by 4x gives you positive 1 by 16x squared. And then minus 1 by 4 into minus 1 by 8 into plus 1 by 8x squared gives you minus 1 by 32x cube. Now, because if you multiply 1 by 4x with 7 by 96x cube, you're going to get a term in x to the power of 4. We will skip that. We are asked to only expand up to the term in x cube. And we also need to simplify all the terms. So we picked up 1. We picked 1 by 4. We are done with these two. Now we will move to the next term, which is 1 by 16x squared. So 1 by 16x squared into 1 gives you minus 1 by 16x squared. And then we have minus 1 by 16x squared into minus 1 by 4x. So 1 by 4 into 1 by 16 gives you 1 by 64. And the negatives get multiplied to a positive. So 1 by 64x cube. And lastly, we are done with this one, because if you multiply 1 by 16 with 1 by 8, you have a square in here and a square in here. And both of these are going to result in a term that has a power of x to 4. So negative 195 by 192 into 1 gives you negative 5 by 192 x cubed. And we won't write down any terms further because those are all of higher orders. Now let's simplify. So we have 1 in here. There is no other term that has only a number with it. So 1 stays as it is. Then we pick out all the x related terms. So we have minus 1 by 4x in here and minus 1 by 4x in here. So we add these two up. This is going to give us minus half x. Then we have the terms in x squared, which is 1 by 8x squared. Then we have 1 by 16x squared. And lastly, minus 1 by 16x squared. So after adding and subtracting, we get plus 1 by 8x squared. And then we have minus 7 by 16 x cube minus 7 by 16. Then we have minus 1 by 32 x cube plus 1 by 64 x cube and minus 5 by 92 x cube. So we are going to add all of these terms. Minus 7 by 96 minus 1 by 32 plus 1 by 64 and minus 5 by 192 from your calculator is going to give you minus 11 by 96 x cube, and this is our answer. I hope this is clear. All we had to do was pick out the terms which were similar in the power. In the other method that we have, the method that requires simplification of this one, in the other method, what we have to do is so in the other method, what we do is we take 4 common initially from here. So we simplify inside the bracket first. From the numerator, we take 4 common. So we get 1 by 3 by 4, 1 minus 3 by 4x. And from the denominator, if you take 3 common, 4 common, what do you get? 1 plus 3 by 4x. Now inside the bracket, you have both 4 in here. So what you can do is you can cancel these 4's out. So you will have 1 minus 3 by 4x and 1 plus 3 by 4x. And you will have a 1 by 3 over it. So now you can simply write this as 1 minus 3 by 4x to the power of 1 by 3, 1 plus 3 by 4x to the power of negative 1 by 3. It depends on you on which method you want to follow. Because this 1 minus 3 by 4x to the power 1 by 3, 1 plus 3 by 4x to the power 3. See, this is exactly similar to this step that we got in here. So whichever method you want to follow, you can follow. And in both of these cases, you are going to end up with the same answer. So what we did in here was, we were first asked to simplify, expand and simplify. So we expanded using the formula. We simplified each of the terms from the calculator. And then we were asked to find the range in which both of these expansions are valid. So we saw that in both of these expansions, the second term is 3 by 4x. So that should be less than 1. And from there, we found out the range of values of x for which the expansion is valid. Now, in the last part of the question, we were given this fraction, this algebraic fraction raised to the power of 1/3. And then we were asked to expand this. In order to expand this, what we did was, we know that everything, in order for us to expand, everything must be in the numerator. So this 4 minus 3x, we took this in the numerator first. After we took this in the numerator, our next step was to take 4 common from both of this, because if we want to apply the factorial formula, we have to take the 4 common. So we took 4 common and we got to a stage in like this, where we multiplied the numbers and they cancelled each other out, where we got 1. We do not write the 1 in here. And then we had the expansions multiplied, 2 terms multiplied, where the expansions we have already found out in parts A and B. So we multiplied the expansions normally. We know when we have terms like this, where we have, let's say, 3 plus 5x and 2 minus 3x, terms like this, we know that we first pick out a term, we pick one term, and then we multiply both of these with this term, and then we pick one term again from here, and then we multiply both of these from that term. So we did the same thing. We picked 1 first, we multiplied all of this with 1. We got these first 4 terms with 1, and then we picked 1 by 4. With 1 by 4, we got the next 3 terms. Then we picked 1 by 16x squared. With 1 by 16x squared, we got the next 2 terms. And with minus 5 by 192, we got the last term. After this, we just normally added and subtracted to get our final answer. In the next part of the question, this is the sum that we will be discussing, where we are asked to expand this up to the term in x cube. By now, it's an easy task for us. We can expand this up to x cube without any hesitation. So when we expand this, our results is, I hope you can expand this on your own. I will just write the final result. So the final result for this expansion is, this is cube root of 1 plus 6x. So when we need to expand this, what we will have to do, we have to first convert it into power. So we will get 1 plus 6x. We know for cube root, for square root, the power is half. For cube root, the power is 1 by 3. So we will apply the formulas for expansion that we have learned, the factorial formula. And from there, we get 1 plus 6 into 1 by 3, which is going to give you 2x. And then the n minus 1 divided by 2 factorial part, that if you use, you're going to get minus 4 x squared. And for the next part, you are going to get 40 by 3 x cubed. It says that now you have to substitute x is equals to 0.04. In the previous sum that we saw, we did not use any specific value for substitution. It was not given to us. We had to find it on our own, but this time we are given this exact value for substitution. So we will apply that in the expansion, in the value of x. If you put in the, we know that if we want to put this value, we have to put this in both the left and the right side of the expansions. So on the left side, we have 1 plus 6x to the power 1 by 3, or simply this. So here we are going to put 1 plus 6 in place of x, 0.004. And then on the other side, we have 1 plus 2 in place of x, you put 0.004. Then we have minus 4 in place of x, you put 0.004 squared, and then plus 40 by 3, 0.004 cube. So if you put this on both sides of the expansion, because that is our first task, we have to substitute this and then find an approximation. So we have substituted that. So when we have substituted that, our next task is to find out the value. So if you put 1 plus 6 into 0.004 in the calculator, it is going to give you a nice fraction, which is cube root of 128 by 125. And on the other side, you have to put everything in the calculator. 1 plus 2 into the value of x, and then you have 4 into the value of x squared, and then you have 40 by 3 into the value of x cubed. The value of x is 0.004, and if you put that in the calculator, you're going to get a very big number, which is 1.007936853. We are going to use the entire value to maintain the accuracy of the question. The estimate that is asked in the question, in order to find the accuracy, maintain the accuracy for that one, to get a very precise answer, we are going to use the entire value that our calculator displays. Now, we have cube root of 128 in here, and then cube root of 125. So we know if you have a cube root over the entire thing, the root gets distributed. So you have cube root of 128 in here, and you have cube root of 125 in here. And this gives us 1.007936853. So now if you multiply that with 125, what if you evaluate this part, cube root of 128, you are going to get a very big decimal number from your calculation. You're not going to get any exact value. So how do you deal with this part? See, we know that if we do a prime factorization for 128, you're going to get 128 divided by 2. That gives us 64. Then divided by 2 gives us 32. Divided by 2 again, 16. Divided by 2, 8. 2, 4, 2, 2. So 1, 2, 3, 4, 5, 6, 7. So 7 2s. So we have 1, 2, 3, 4, 5, 6, 7 2s. Divided by cube root of 125 is simply 5. And this is equals to 1.00796793685. Now 5 gets multiplied in there simply. And what happens inside the root? So we know for cube root, for square root, the shortcut was for every 2 number, 1 number comes outside. For cube root, the shortcut is for every 3 number, 1 number will come outside. For every 3 number, 1 number will come outside. So we are going to get this 1, 2 will come outside, and from here 1, 2 will come outside. So these two 2's get multiplied, and you have cube root of 2 in here. And this 5, my bad, this 5 gets multiplied to the other side, and you get a very big number, which is 5.039684267. Now, this 2 into 2 gets multiplied, and we get 4 in here. So we have 4 into cube root of 2, which is equals to 5.039684267. This 4 goes and gets multiplied in divided in there. So we have cube root of 2 is equals to this big thing divided by 4 gives you 1.25992167. So this is what exactly our question asked us to find. We were asked to find an approximate or an estimate to cube root of 2. And we have found that one out. The precision was not asked in the question. If in the question it mentioned we have to give our answers to 5 significant figures or 7 significant figures, we will round it up till that. But since nothing is mentioned in the question, it is up to you in which you answer. So I hope this one was clear. It was not a very difficult one. We were first asked to expand. By now we should be able to expand on our own. Then in the next part, we were asked to substitute the value of x as 0.004 to find an approximate. So this part is the latter part of the question. We will deal with it later. Our first thing mentioned in the question was to substitute the value of x as 0.004. So 0.004 was substituted on the left side, and on the right side of the expansion we substituted. After substituting, we tried to simplify it. So when we simplified, we reached a case like this. From there, we got cube root of 5 in here, cube root of 125 as 5, and then we simplified cube root of 128. Afterwards, we saw that in the next part of the question, we were asked to find an approximation to cube root of 2. So in order to find an approximation to cube root of 2, we kept cube root of 2 on one side and took everything else to the other side. And while doing so, we reached our final answer, the final estimate that was asked in the question. I hope this has helped. Now, in the next part of the question, the next sum, we are asked to find the coefficient of x cube of this fraction given to us. So this fraction we see has a power in the denominator. So we know that in order to use the binomial theorem or the factorial formula, whichever formula we want to use, we first have to bring everything to the numerator. So we will do that. We have 1 plus 3x divided by 1 plus 2x to the power of 3. So we will bring that in the numerator. We have 1 plus 2x to the power of minus 3. Now we see that for negative powers, we cannot use the binomial theorem related formula. So what will we do? We will use the factorial formula. So for 1 plus 3x, it will stay as it is. There is no power over it. So that is not a headache for us. And for 1 plus 2x to the power of minus 3, we will apply the factorial formula. So when we apply it, what do we get? We get 1 plus nx. And then we have n minus 1 divided by 2 factorial into x square. Then we have n minus 1, n minus 2 divided by 3 factorial into 2x cube. We won't continue any further because we were asked to find the coefficient of x cube. So we will stay till the term in x cube. So from here we have 1 plus 3x as it is. And if you simplify this, we get 1, then minus 3 into 2x gives you minus 6x. Then we have minus 3 into minus 3 minus 1, which is minus 4, divided by 2 factorial, which is 2, into 2 square, which is 4. And if we multiply, we get 24 x squared from here. And from here, you are going to get if you multiply everything, then you are going to get 80 x cube minus 80 x cube. Now we are asked to find the term in x cube. We have to only find the coefficient of x cube. In order to find the coefficient of x cube, let's first find the term in x cube. So what is the term in x cube? It means we will pick out the numbers that when we multiply, we get the term in x cube. So let's pick that one out. So you have 1 in here. So what should we multiply with 1 to get x cube? We have 1 in here. So 1 into 1 is going to give us a number. Multiplied with 6x is going to give us a term in x. Multiplied with this one is going to give us a term in x squared. If we multiply with this, then we get a term in x cube. So 1 multiplied with minus 80 x cube gives us a term in x cube. Then if we pick 3x, what do we get? When we pick 3x, with 3x, if you multiply 1, you're going to get a term in x. Then 3x into 6x, you're going to get something in x squared. But if you multiply 3x with 24x squared, if you multiply 3x with 24x squared, you're going to get a term in x cube. So if you multiply this, 1 into 80 gives you minus 80x cube. And then 3x into 24x is going to give you 72x cube. So 70 minus 80 plus 72 is going to give you minus 8x cube. That is your term in x cube. So if the term in x cube is minus 8x cube, then what is the coefficient? We know that whatever is with x, that x cube, that becomes the coefficient of x cube. So our coefficient of x cube would be minus 8. And this is our answer. This was an easy sum. And I hope that there is no problem in this one. With this, we are done with the basics of binomial expansion. And more or less, you should be able to solve the sums from the question paper with the help of this one. That's it for today's lecture.